Today's lesson, equations of lines in y equals mx plus b form. All I want you to get from that title is that we're going to be talking about lines today. And the y equals mx plus b form, that'll be my job today to explain what y equals mx plus b form means. Hopefully that'll be perfectly clear by the end. Okay, so once upon a line. Consider the following scenario. And apparently bicycles are going to be involved. So Juan has a job assembling bicycles. Each day he is paid $40 plus an additional $5 for each bicycle he assembles. This is often called piecework, where you get some money to be there at your job, but also you get some money based on how much work you get done. This works for the employee and the employer equally as well, I think. The employee can make extra money if they want to work extra hard, and the employer only has to pay extra money when stuff is getting done. So it's one way of getting paid. Now, if we drew a graph to show Juan's daily earnings based on the number of bicycles he assembles, what would the graph look like? Well, let's think about what would happen is that Juan would start at some base amount at $40, and each time he added on a bicycle, he'd add on exactly $5 to his graph. And if you think about that shape for a minute, it means whatever graph we make is going to be going up by the same amount all the time, and what we'll get is a line. And that's what we're talking about for most of this chapter, is situations where the graph turns out to be a line. So we'll always be thinking about what does it take to make the graph of a line. Now, how do we know the graph will be linear? Notice we say linear there. When we say something's has a line shape, we call it linear. And how do we know that the graph will be linear? Because in this situation, the graph will start at a certain value, and then will go up by a certain amount every single time. In this case, it was going up by $5 every single time. If that's not perfectly clear, I'm going to show you the graph. I'm not trying to make it a mystery or anything like that. I'm just trying to establish that when we look at a situation like this, we can tell whether it's going to be a line or not, if it's going to be going up by the same amount every single time. Okay, so to set up an equation for this, we should choose a variable to represent Juan's daily earnings, and a great choice for earnings would be E. And then we need a variable to represent the number of bicycles Juan assembles, and B would have been a great choice, but I happen to choose N here for number of bicycles. And lots of times when we're talking about the number of something, we'll use the letter N because it just is a nice letter to represent number of something. Now, what is the start value of this relationship? Where does Juan's earnings start? And he starts at $40 each day. Each day he gets his $40, and then he adds on to that based on how many bicycles he makes. So then, what is the rate for this relationship? How much is it going up by every single time? And they tell us right in the question. It goes up by $5 for each bicycle he sells. So that's how much he gets for each extra bicycle. Now, create an equation. Well, an equation will look like this. His earnings will be based on two things: how much he gets per day, and then how much he gets per bicycle. The per day amount is a constant. He gets $40 per day. And the number of bicycles, well, that depends. It depends on how many bicycles he makes. So he has to multiply $5 times the number of bicycles he makes. So what we get here is an equation. He starts off with $40, plus he gets more. He gets $5 times the number of bicycles. You can imagine using this equation to go, okay, let's say he made 10 bicycles. Well, he'd get $40 plus 5 times 10. If he made 20 bicycles, I don't know if that's possible, but he'd make $40 plus 5 times 20. So it's always 40 plus 5 times the number of bicycles he makes. So that number by itself, the constant, is his start value, and then the number that gets multiplied by the variable is the rate. It's always going to be with the rate there. Now here's the graph. Again, I just had to do it in a certain order here. I wasn't trying to be mysterious about the graph. The graph here will start at 40. And then for each bicycle, go up by 5. And now maybe it makes it clear why when you're going up by the same amount every time, you get a line. Because it's just going up by 5 every time. So I draw a line through it to show that shape. Please use a ruler when you're drawing lines yourself. Questions for discussion. Is it really appropriate to draw a line through the points in this example? Well, technically speaking, let me just go back. when we draw a line through, we're sort of implying that any number of bicycles is possible, and that's technically not true. Like Juan couldn't go into work today and make 3.5 bicycles and have that point right there at 3.5. So, or he can't make like 5.8 bicycles and have that dot right there. So you can't have any number of bicycles here in this particular situation. We'll talk more about this as the chapter goes along. Don't get too worried about it. But we just sort of mentioned technically that we're only drawing the line here to show the shape. It's not really technically the right thing to do here because all those dots between are not real dots. We can't have those values. We can't have decimal values for bicycles. Someone might say maybe at the end of the day, he's done half a bicycle. So yeah, I guess you could build half a bicycle. But the point is he wouldn't get paid for it. So you couldn't find his earnings on that. And do we really need all the points? No. As you get better at drawing lines, you will find that you don't need to draw all the points. By the time you have maybe 3 or 4 points, you can get your ruler on the page and draw the rest of the line. So yes, that's a definite shortcut here. But for the first few examples, we'll draw all the points so you can really see what's happening. So making the switch to y equals mx plus b form. Consider this. Moving forward, when we did it, we put the constant value or the start value first, and then we put the rate with the variable second. For a lot of reasons that aren't clear now, you're just going to have to trust me at this point. That's going to work a lot better for a lot of things that we're doing is if we put the variable combination first. And some of that won't even become clear until grade 10 and 11. But for now, just trust me, it's going to work better overall if we don't have to. It's not a must, but if we usually switch the order of these things around, instead of having the start value as the first number and the rate with the variable as the second term here, we'll just switch those around. More common, you'll see this. It's not wrong not to do this. It's just you're going to see this more and more, that it's going to have a lot of advantages to have the rate with the variable first and the start value second. I know that sounds weird when I say that, having the start value second. But it's the same information, just in a different order. And when we write it that way, we call it y equals mx plus b form. And the reason it's called y equals mx plus b form is it says y equals. It starts with y equals. And then the first number is the m, that 5 is the m, and then we have an x there, and then plus a number by itself. And that's really the same things we said before, is that we've got a term with a variable in it, and then a term that doesn't have a variable in it. And that term that doesn't have a variable in it is called the constant term. Lots of practice on this coming up. So if it's like, okay, I sort of get what you mean, then that's fine. That's good. If you sort of get it, that's good enough for now. So here it is in the fancy box to really show how important it is. It might be the most important equation of grade 9. Y equals mx plus b. I don't say it's complicated. It's not all that complicated, actually. It's a pretty simple thing. You put the rate right there by the x, and you put the start value right there all by itself. And that's y equals mx plus b form. So some examples. Draw a graph for each of the following. Y equals 3x plus 2. So if we're going to draw a graph, we need to know where does it start, and the start value will be this number by itself. And then this number that's with the variable is the rate. So when I go to graph, I'm going to need a scale on my graph here first. So here we'll just go by ones in this particular situation. Where does it start? It starts at 2. And it's going up by 3 each time because 3 is the rate. I'll draw a line through there with my ruler. All there is to these questions is to go, okay, what's the start value? And here it's 60. The number by itself is the start value. And then the number that's with the variable is the rate. So we start at 60. We need a better scale this time. I chose a scale going up by 5s this time so I could get up high enough to get up to 60. Start at 60, and this time going down by 10s. Again, do you need all those points to draw the line? No. We sort of set a rule in grade 9 that you should get 3 or 4 points at least before you get your ruler out and draw the line, just to make sure you're going in the exact right direction. So we slipped some negatives in there. Negative just means the rate is going down. So you might think about a hot air balloon coming down towards the ground. So it would be going down 10 every single time or something like that. So negatives are possible here. So can we use negative numbers? Well, yeah, we can use negatives in the rate, but we can also use negatives as the x values. So in this question, it's y equals 4x plus 1. Let me just write this on every time. I encourage you to write this every time. As soon as you get an equation like this, right beside the number by itself, that's the start value, and the number with the x, that's the rate. Now, we want to change slightly what I mean by start value. Every time we did start value, we did start on the y-axis. That's what we meant by start value. Right from the beginning, in the one example with the bicycles, that start value was, where does it start on the y-axis? So when the whole set of axes comes in, when the whole Cartesian plane comes in like this, it gets a little confusing about what you might mean for start value. So I just want to modify what I said earlier and add to it a little bit for clarity, is that y value, sorry, that number that's by itself, it's the start value on the y-axis. And I'll give something away. In a couple of sections, we're going to start calling it the y-intercept. That's how important it is. It gets a special name, the y-intercept. And I don't want to confuse you too much with that today. So for today, go ahead and call it start value on the y-axis. That'll help you know where to put it. And so in this question, 1 is the start value on the y-axis, and I got to go up by 4s because the rate is 4. Now I can go into negative numbers. I just have to go backwards, continuing to follow the pattern. Like if adding 1 adds 4 on, then subtracting 1 subtract 4 off. I'm just going backwards there. So I hope that's not too confusing for you, that you just got to continue the pattern when you're going into negative values. And then draw the line. Y equals 2.5x minus 3. Okay, we're not going to get too carried away with decimals and fractions today. I don't want you to worry too much about decimals and fractions, because actually, for once, fractions will go very well in this chapter. It'll be fine. But we need to talk about something called slope a little more, and so we'll talk about that in the next lesson. Don't panic too much about decimals and fractions. Here we can handle 0.5s, because 0.5s aren't too crazy. So in this particular case, again, I want to every time put here. So if you're having any trouble in the homework, come back to this and say, okay, this number by itself is called the start value, and I've added a little bit onto that. That's start value on the y-axis, and then this one is the rate. So in this particular situation, I start at -3 on the y-axis, and then I'm going up by 2.5. But because that was a nice decimal, it's not too hard to work with. Go up by 2.5 each time, up by 2.5, up by 2.5, up by 2.5. More points helps to make sure you get the line straight. But like I say, 3 or 4, and you should have enough. And all I'm doing when I go into the negatives is just continuing the pattern into the negatives. No big deal there. One last example. Like all math problems, as soon as we ask it one way, we like to talk about how to do it in reverse. And so on all the other questions, it was, here's the equation. You make the graph, and this time we have the graph, and now we want to make the equation. So to get the equation of the line, we first need that start value. Where does it start? On the y-axis. See how that phrasing becomes important? Because where does this line start? Well, it's hard to know where it starts. But when we say start, we mean something specific. We mean, where does it start on the y-axis? And this one starts at -2. There it is right there, starting on the y-axis. And its rate, well, we just got to find another point to use here, and that point right there is a good choice to use. And we see it's gone, when it's gone over 1, it's gone down 3. So the rate is -3. And then I'm ready to make my equation. You might have to go look back at that fancy box to know where everything goes. And the equation looks like that. -3 is the rate, so it goes with the x. And then the -2 is the start value, so it goes out there by itself. The homework today is a sheet you got to print out. It's not from the textbook, but it's very important homework to get all these words down pat. Again, I'm saying it's so important, but I don't know that it's particularly difficult. You just have to really know y equals mx plus b and which each of those numbers means. But make sure you go through it carefully, because it's important moving forward that we have all that fairly simple stuff down pat. Have a great day.